a little bit more complicated, something that I'm going to talk about in a minute, but it's filled with deposits from the beach, for example, okay? But this material down here was definitely deposited by a stream, all right? Now, if you look off to the right here a little bit more, what else? Let's look at this part of the outcrop specifically. So I see igneous rock, yes, overlaid by sedimentary rock, right? Igneous rock is older. Sedimentary rock is younger. What's this? Igneous rock. It's on top of sedimentary rock. Why? Does that make sense? Sedimentary rock has to be deposited on top of igneous. Well, if I keep looking up, oh, there's sedimentary rock up there again. In fact, that sedimentary rock up there is the same as this sedimentary rock down here. Look at that right here. This very nice linear feature. It's a fault. It's a fault. It's a fault with tectonic displacement. This whole outcrop is shoved up above this outcrop. It's all the same unit. I think this thing. See that? Who wants to describe to me what they see? Starting here on the left and working your way to the right. Okay, yeah, very red rock means oxidation, yes. Iron. Could be igneous on the bottom, sedimentary on the top. There's definitely two layers here. Can't really tell from here exactly what they are, right?
It looks like it was a stream bed here.
Very different texture. There's a lot of layers up there. Can you tell me about the layers that you see up there in the red stuff? They're kind of dipping. Close, yeah. But do you see how they're kind of all dipping away from you? There's like pretty serious layers going away like that. And then there's what? There's like a big dark line. Yeah. And then there's more stuff underneath. It's very light colored. Also seems pretty layered, but not the layers don't seem to be in the same direction, do they? On the low part here, we'll look at it up close in a minute also. Yeah, there's some sort of shift going on here. Something was deposited, and then on top of it is deposited in a different way. We're going to talk about that in a second. What do you see off to your right here? The right,
A house. Is this like a
landslide, absolutely. Mass wasting. This is a perfect example of mass wasting. What did I tell you about the different parts of the landslide? What's at the top of a landslide? A cliff, right? A scarp. We call it a scarp, a head scarp. Can you see the head scarp, the really steep cliff that wraps around this bulge? Yeah. Notice the trees that are on top of it used to be up at the top of the other tree, right? And now they're all tilted forward and falling over, right? Yeah. This whole mass of soil used to be like this cliff, standing up nice and tall, and then as it got eroded away at the toe, everything just slumped, fell down. And now, what did I say about the body of the landslide? It's hummocky, it's uneven, and then it steepens at the toe. There's a little bulge. You can see it's flat where the trees are, and it's all bumpy and hummocky, and then it kind of steepens at the toe where you can see, right? That's where things just kind of came to us. So that's a very perfect example of mass wasting and landslide. Okay? So, yes.
Mass wasting, is it just the sedimentary rock, or is it like all of it that comes down?
There's a weakness plane forms in the rock, and it just kind of falls
that
along
section
it.
falls.
Yeah, whatever's above it falls, because its weight, it's too heavy for the soil properties. Remember I mentioned the cohesion and the friction of the grains? They like to be in a certain position, and if you put too much weight on them, they'll move. And so essentially the balance of the mass and the resistance of the friction and cohesion got unbalanced, the mass became too high, and it all fell. Does that make sense? There's driving forces, mainly the mass, and there's resisting forces, which is friction and cohesion.
Is there any way to tell, like, from the mass, like, where the cohesion is, or would you have to, like, start taking it all off?
Well, the cohesion is just the concept of the grains gluing together, and friction is the concept of the grains sliding past each other. What you're talking about is the slide plane, where things move. You have an idea of it because you can see where the cliff is in the back, and that kind of extends downward beyond it, behind this whole thing, but you'd really have to dig in there to see where things slip. Okay, so let's have a closer look at this outcrop over here to try and figure out why exactly we see these differences in what's above and what's below. And think about what that dark layer is, okay?
Organic matter.
Organic matter. Heard it. We'll have a look. So is it igneous rock? No, it's a sedimentary rock, okay? It's not the same stuff as what we saw over there. That stuff over there is probably deeper down. Yes. Why is the sand different right here with respect to that sand over there? That makes sense? This sand comes from there. That sand comes from the ocean. It's pretty uniform. That's a very good observation. Okay. So do you see sort of this flat layering here in the sedimentary rock? It was deposited that way, okay? And then you see this dark layer, someone said it earlier. Organic matter. It's coal, okay? There used to be a soil horizon here. There were plants growing right where that dark layer is, right? And then for some reason, things changed. The environment changed, and all that sand above it got deposited, right? And so there was a nice, lush, marshy land, most likely, okay? And then things maybe dried up all of a sudden. Maybe this whole area got uplifted high enough that the water table conditions were different, so everything sort of dried out and died, and then it created this layer of coal, okay? Peat. All right? So what about this sand above it? It looks pretty wispy, doesn't it? Yeah, and the layers kind of go back. Well, guess what? The environment changed, it got really dry, and you moved to a sand dune environment. Those are wind-blown sediments that are deposited on top of this marshland, essentially. Okay? So things got dry, and the wind picked up, and it brought all this sediment out here towards the beach. The sand got deposited. It's a very fine-grained sand if you can touch any of it. Okay? And you see the nice layering. That's nice fine layering because the wind blows it in very fine little layers. And you know the shape of a sand dune? Yeah? It kind of makes, you can see that this was an ancient sand dune. Okay? And then it became over time a sedimentary rock, loosely, it's a loosely binded sedimentary rock, okay? Because it's not very old. It didn't get submitted to very high pressures. It hasn't had time to really glue together to become hard yet. But it's a rock nonetheless. It's a weak rock. Okay? The wind blew it. Yeah, sand dunes would take that very typical form because the wind blows and deposits the sand, and then it like falls over. It makes these layers. Interesting. Okay, so now that we know this up close, let's step back again now and really appreciate what we just discussed.